Hey everyone, Bob here. Today I would like to present to you our topic for today, which is on tire service and maintenance, especially for heavy vehicles and also for passenger cars. It is critical that you include in your preventive maintenance or repair and maintenance program the tire servicing and maintenance of all your vehicle's tires and passenger car tires. Although tires are often taken for granted, they contribute greatly to the ride and steering quality of a vehicle. Tires also play a significant role in vehicle safety. Improper types of tires, incorrect inflation pressure, and worn out tires create a safety hazard. When tires and wheels are out of balance, tire wear and driver fatigue are increased, which may create a driving hazard. The purpose of tires may be summarized as one, tires cushion the vehicle to provide a comfortable ride for the occupants. And the second one would be the vehicle weight must be supported firmly by the tires. The third, tires must develop traction to drive and steer the vehicle under a wide variety of road conditions. And the last one would be the tires contribute to directional stability of the vehicle, and they must absorb all the legal force in turns. Proper servicing of tires and wheels is extremely important to maintain vehicle safety and provide normal tire life. Improperly serviced and or balanced tires and wheels cause wheel vibration and shimmy problems, resulting in excessive tire tread wear, increased wear on suspension and steering components, and decreased vehicle stability and steering control. Proper tire maintenance is essential to provide normal life and maintain vehicle safety. When tires are underinflated, tire operating temperatures can increase, tire life is shortened, and worn out tires are a safety concern. And also a lack of tire rotation can also reduce tire life. Tire construction varies depending on the manufacturer and the type of tire. The three main areas of a tire are the beads, carcass, and casing, and the tread. A typical modern tire contains many components, including bead wire, bead filler, liner, steel reinforcement in the sidewall with hard side compound, rayon carcass plies, steel belts, belt cover, hard under tread compound, and hard high grip tread compound. The tire bead contains several turns of bronze coated steel wire in a continuous loop. This bead is molded into the tire at the inner circumference and is wrapped in the cold plies. The bead anchors the tire to the wheel. The bead filler above the bead reinforces the sidewall and acts as a rim extender. Sometimes may be found with sidewall reinforcements to improve their performance if the tire loses air pressure. These tires are sometimes referred to as run flat tires. They may be driven for a short time and distance without air pressure, without serious damage to the tire and rim. They are not meant to run for long periods of time in this fashion, but rather allow the driver to drive the car to a suitable location for changing or repairing the tire. The most commonly used tire designs are bias, belted bias, and belted radial. In bias ply or belted bias tires, the, cos- the cores crisscross each other. These cores are usually at an angle of 25 to 45 degrees to the tire center line. The belt ply chord angle is usually 5 degrees less than the chord angle in the tire casing. Two flies and two belts are most commonly used, but four plies and four belts may be used in some tires. Compared to a bias ply tire, a belted bias ply tire has greater tread rigidity. The, the belts reduce tread motion during road contact. This action provides extended tread life compared to a bias ply tire. In radial tires, the ply cords are arranged radially at a right angle to the tire center line. Steel belts are the most common in radial tires, but other belt materials such as fiberglass, nylon, and rayon have been used. The steel or fiberglass cords in the belts are crisscrossed at an angle of 10 degrees to 30 degrees of relation to the tire center line. Many radial tires have two plies and two belts. Radial tires provide less rolling resistance, improve steering characteristics, and longer tread life compared to bias ply tires. Regardless of the type of tire construction, the tire must be uniform in diameter and width. Radial runout refers to variation in tire diameter. A tire with excessive radial runout causes the tire thumping problem as the car is driven. When a tire has excessive variations in width, this condition is called lateral runout. A tire with excessive lateral runout causes the chassis to waddle when the car is driven. The tire plies and belts must be level across tread area. If the plies and or belts are not level across the tread area, the tire is cone-shaped. This condition is referred to as tire conicity. When a front tire has conicity, the steering may pull to one side as the car is driven straight ahead. A rear tire with conicity will not affect the steering as much as a front tire with conicity. A great deal of important information is molded into the sidewall of the average car or light truck tire. The tire rating is part of the information located on the sidewall. The tire rating is a group of letters and numbers that identify the tire type, section width, aspect ratio, construction type, rim diameter, load capacity, and speed symbol. For example, when a tire has a P21565R1589H rating on the sidewall, the P indicates a passenger car tire. The number 215 is the size of the tire in millimeters measured from sidewall to sidewall, with the tire mounted at the recommended rim width. The number 65 indicates the aspect ratio, which is the ratio of the height to the width. With a 65 aspect ratio, the tire's height is 65% of its width. The letter R indicates a radial ply tire design. The number 15 is the rim diameter in inches. The number 89 represents the load index. This load rating indicates the tire has a load capacity of 1,279 pounds. Various numbers represent different maximum loads. Some tires manufacturers use the letters B, C, or D to indicate the load rating. The letter B indicates the lowest load rating, and the letter C represents a higher load rating. A tire with a D load rating is designed for light-duty trucks. Many tires sold in the US are speed rated with various letters that indicate the maximum speed capabilities of the tire. The letter designation for the speed rating is included on the sidewall markings. Although tires may be speed rated, tire manufacturers do not endorse the operation of a vehicle in an unlawful or unsafe manner. Speed ratings based on laboratory tests, and these ratings are not valid if tires are worn out, damaged, altered, underinflated, or overloaded. Tire speed ratings do not suggest that vehicles can be driven safely at the designated speed rating because many different road and weather conditions may be encountered. Also, the condition of the vehicle may affect high-speed operation. Some other tire ratings available from the manufacturers include tread wear, traction, and temperature resistance. Tread wear ratings allow consumers to compare tire life expectancies. When the tires are tread wear rated, they are installed on a vehicle and driven on a test course for 7,200 miles or 11,587 kilometers. Treadwear is calculated after this test course run, and the mileage the treadwear out is determined from this calculation. The projected mileage is adjusted for test condition variation as compared to 30,000 miles or 48,279 kilometers on the test course. This calculation provides a number or ratio to compare various tires. For example, a tire with a 150 tread wear rating will provide 50% more tire wear mileage than a tire with a 100 tread wear rating. To obtain maximum tire tread life, most vehicle manufacturers recommend tire rotation at a specific mileage intervals. Puncture sealing tires are available as an option on certain car lines, and some rubber companies sell these tires in the replacement tire market. These tires contain a special rubber sealing compound applied under the tread area during the manufacturing process. When a nail or other object up to 3 over 16 inch in diameter punctures the tread area, it picks up a coating of sealant. If the object is removed, the sealant sticks to the object and is pulled into the puncture. This sealant completely fills the puncture and forms a permanent seal to maintain tire inflation pressure. Puncture sealing tires usually have a special warranty, and these tires can be serviced with conventional tire changing and balancing equipment. Some luxury sport type vehicles are equipped with run flat tires. Run flat tires eliminate the need for a spare tire and a jack on these cars. This provides a weight and space savings. Run flat tires must minimize the difference between run flat tires and conventional tires and provide sufficient zero pressure durability so the vehicle can be driven a reasonable distance to a repair facility. Some flat tires have stiffer sidewalls that partially support the vehicle weight without air pressure in the tire. Other run-flat tires have a flexible rubber support ring mounted on a special rim to support the vehicle weight if deflation occurs. Most tires have tread wear indicators built into the tread. When the tread wears a specific amount, the wear indicators appear as bands across the tread. Some manufacturers recommend tire replacement when the wear indicators appear in two or more tread grooves at three locations around the tire. If replacement tires have different size or construction type than the original tires, vehicle handling, ride quality, and speedometer odometer calibration may be seriously affected. When replacement tires are different size than the original tires, the vehicle ground clearance and tire to body clearance may be altered. Steering and braking quality may be seriously affected if different sizes or types of tires are installed in the vehicle. The temporary spare tire can also affect the vehicle handling, and the driver must keep this in mind when the use of the temporary spare is required. Many vehicles manufactured in recent years are equipped with ABS. When different size tires are installed in these vehicles, the ABS operation can be compromised, which may result in serious braking defects. The tire valve allows air to flow the tire and is also used to release air from the tire. The core in the center of the valve is spring-loaded and allows air to flow inward while the tire is inflated. This valve is very similar to the Schrader valve used in the air conditioning and fuel systems. Once the tire is inflated, the valve core sits and prevents airflow out of the tire. The small pin on the outer end of the valve core may be pushed to unseat the valve core and release air from the tire. An airtight cap on the outer end of the valve keeps dirt out of the valve and provides an extra seal against air leakage. A deep groove is cut around the inner end of the tire valve. When the valve assembly is pulled into the wheel opening, this groove seals the valve in the opening. Since cars have been downsized in recent years, spare and weight have become major concerns for vehicle manufacturers. For this reason, many car manufacturers have marketed cars with compact spare tire to provide a weight and space savings. The high pressure mini spare tire is the most common type of compact spare. This compact spare rim is usually 4 inches wide. The compact spare rim should not be used with standard tires, wheel covers, or trim rings. Any of these uses may result in damage to these items or other parts of the vehicle. The compact spare should be used only on vehicles that offered it as original equipment. Inflation pressure in the compact spare should be maintained at 60 psi or at the manufacturer's recommendation. The compact spare tire is designed for temporary use until the conventional tire can be repaired or replaced. The driver should limit driving speed to 50 miles per hour or 80 kilometers per hour and distance to 50 miles or 80 kilometers. When the high pressure mini spare is installed on a vehicle, the space saver's spare tire must be inflated with a special compressor. Battery voltage is supplied to the compressor from the cigarette lighter. This type of compact spare should be inflated to 35 psi. After the tire is inflated, be sure that there are no folds in the sidewalls. The lightweight skin spare tire is a bias ply tire with a reduced tread depth to provide an estimated 2,000 miles or 3,200 kilometers of tread life. This type of spare tire is also designed for emergency use only. Driving speed must be limited to 50 miles per hour or 80 kilometers per hour when this tire is installed on the vehicle. Always inflate the lightweight skin spare to the pressure specified on the tire placard. The tire contact area refers to the area of the tire that is contact that is in contact with the road surface when the tire is supporting the vehicle weight. The free diameter of a tire is the distance of a horizontal line through the center of the spindle and wheel to the outer edges of the tread. The rolling diameter of a tire is the distance of a perpendicular straight line through the center of the spindle to the outer edges of the tread when the tire is supporting the vehicle weight. The rolling diameter is always less than the free diameter. The difference between the free diameter and the rolling diameter is referred to as deflection. Tire tread grooves take up excess rubber and prevent scrubbing as the tire deflects in the contact area. The correct air pressure exerted evenly against the entire interior tire surface, which produces tension in the tire carcass, supports the vehicle weight. Therefore, tire pressure is extremely important. Under inflation decreases the rolling diameter and increases the contact area, which result in excessive sidewall flexing and tread wear. Overinflation decreases the contact area, increases the rolling diameter, and stiffens the tire. This action results in excessive wear on the center of the tread. Tire pressure should be checked when the tires are cool. Since tire pressure normally increases at high tire temperatures, air pressure should not be released from hot tires. Excessive heat buildup in a tire may be caused by underinflation. This condition may lead to severe tire damage. On many vehicles, the tire placard is permanently attached to the rear face of the driver's door. This placard provides tire information such as maximum vehicle load, tire size, including spare, and cold inflation pressure, including spare. The vehicle manufacturer carefully calculates tire pressure to provide satisfactory tread life, handling, ride, and load carrying capacity. Most vehicle manufacturers recommend that tire pressures be checked cold once a month or prior to any extended trip. The manufacturer considers the tires to be cold after the vehicle has sat for 3 hours or when the vehicle has been driven less than 1 mile. The tire should be inflated to the pressure indicated on the tire placard. Tire pressure may be listed in the metric or USC system values. The US has passed legislation that requires all passenger cars and light trucks under 10,000 pounds of gross vehicle weight to eventually be equipped with tire pressure monitoring systems. The main purpose of this system is to warn the driver if their tires are losing air pressure, leaving the tires underinflated and dangerous. Rims are manufactured from stamped or pressed steel discs that are riveted or welded together to form the circular rim. Some rims are cast aluminum alloy wheel rims or cast magnesium alloy wheel rims. Sometimes these wheels are referred to as mug wheels. These wheels are lighter and generally more accurately designed than pressed steel wheel rims. The rim offset is the distance between the rim center line and the mounting face of the disc. If a rim is designed with a positive offset, it has the mounting face outboard of the rim center line. A rim with negative offset has the mounting face inboard of the rim center line. This rim offset affects front suspension loading and operation. The width of the wheel is measured between the rim flanges. Rim diameter is determined by measuring across the wheel from the top to the bottom. Rim back spacing is the inside depth of the rim. It is measured from the backside of the rim to the mounting surface of the rim. A large hole in the center of the rim fits over the flange on the mounting surface, and the rim has a small hole for the valve stem. The wheel stud mounting holes in the rims are tapered to match the taper on the wheel nuts. A drop center in the rim makes tire changing easier. Rims have safety ridges behind the tire bed locations, which help to prevent the beads from moving into the drop center area if the tire blows out. If the tire blows out and a bead enters the drop center area, the tire may come off the wheel. Replacement wheel rims must be same as the original equipment wheels in load capacity, offset with diameter and mounting configuration. An incorrect wheel can affect tire life, steering quality, wheel bearing life, vehicle ground clearance, tire clearance, and speedometer or odometer calibrations. When a wheel and tire have proper static balance, the weight is equally distributed around the axis of rotation, and gravity will not force the wheel to rotate from its rest position. If a vehicle is raised off the floor and the wheel is rotated in 120-degree intervals, a statically balanced wheel will remain stationary at each interval. When wheel and tire are statically in balance, the tire has a heavy portion at one location. The force of gravity acting on this heavy portion will cause the wheel to rotate when the heavy portion is located near the top of the tire. Centrifugal force may be defined as the force that tends to move a rotating mass away from its axis of rotation. As we have explained previously, the tire and wheel are subjected to very strong acceleration and deceleration forces when a vehicle is in motion. The heavy portion of a statically imbalanced wheel is influenced by a centrifugal force. This influence attempts to move the heavy spot on a tangent line away from the wheel axis. This action tends to lift the wheel assembly off the road surface. The wheel lifting action caused by static imbalance may be referred to as wheel tramp. This wheel tramp action allows the tire to slip momentarily when it is lifted vertically. When the wheel and tire move downward as the heavy spot decelerates, the tire strikes the road surface with a pounding action. This repeated slipping and pounding action causes severe tire scuffing and cupping. The vertical wheel motion from static imbalance is transferred to the suspension system and is then absorbed by the chassis and body. This action causes rapid wear on suspension and steering components. The wheel tramp action resulting from static imbalance is also transmitted to the passenger compartment and can cause passenger discomfort and driver fatigue. When a vehicle is traveling at normal highway cruising speed, the average wheel speed would be 850 RPM. A statically imbalanced tire and wheel assembly is an uncontrolled mass of weight in motion. When a vehicle is traveling at 60 miles per hour or 97 kilometers per hour, if a tire has 2 ounces or 57 grams of static imbalance, the resultant pounding force is approximately 15 pounds or 6.8 kilograms against the road surface. A tire depends on correct inflation pressure to maintain its correct shape and support the vehicle weight. Excessive Inflation pressure causes excessive tread wear, hard ride, and damage to the tire carcass. So when the tires are underinflated, these problems may be evident in terms of excessive wear on each side of the tread, hard steering or wheel damage, excessive heat buildup in the tire which can lead to tire failure, and possible severe tire damage with resultant hazardous driving. On most tires, the tread wear indicators appear as white bands across the tread when the tread depth is worn to 1 over 16 inch or 1.6 millimeters. Most tire manufacturers recommend tire replacement when the wear indicators appear across two or more tread grooves at any three locations around the tire. If tires do not have wear indicators, a tread depth gauge may be used to measure the tread depth. The tread depth gauge reads in 30 seconds of an inch, and tires with 2 over 30-second tread depth or less should be replaced. To a large extent, driving habits determine tire life. Severe brake application, high-speed driving, turning at high speeds, rapid acceleration and deceleration, and striking curves are just a few driving habits that shorten tire life. Most car manufacturers recommend tire rotation at specified intervals to obtain maximum tire life. The exact tire rotation procedure depends on the model, the type of tires, and whether the vehicle has a conventional spare or compact spare. Tire rotation procedures do not include the compact spare. The vehicle manufacturer provides tire rotation inflation in the owner's manual and service manual. The vehicle manufacturer usually recommend different type tire rotation procedures for bias tires and radial tires. Uneven trade surfaces may cause tire noises that seem to originate elsewhere in the vehicle. These noises may be confused with differential noise. Differential noise usually varies with acceleration and deceleration, while tire noise remains more constant in relation to these forces. Tire noise is most pronounced on smooth asphalt road surfaces at speeds of 15 to 45 miles per hour or 24 to 72 kilometers per hour. When tire thump and vibration is present, check for cup tire treads, excessive tire radial runout, manufacturing defects such as heavy spots, weak spots, or tread chunking, and incorrect wheel balance. A vehicle should maintain the straight ahead, forward direction, or smooth, straight road surfaces without excessive steering wheel correction by the driver. If the steering gradually pulls to one side on a smooth, straight road surface, a tire steering or suspension defect is present. Tires of different types, sizes, design, or inflation pressures on opposite sides of a vehicle cause steering pull. Sometimes a tire manufacturing defect occurs in which the belts are wound off center on the tire. This condition is referred to as conicity. A cone-shaped object rolls in the direction of its smaller diameter. Similarly, a tire with conicity tends to lead or pull to one side, which causes the vehicle to follow the action of the tire. Tire conicity cannot be diagnosed by a visual inspection. Tire conicity is diagnosed by switching the two front tires and reversing the front and rear tires. Incorrect front suspension alignment angles also cause steering pull.